Hello, everyone. Welcome to our channel. Today, we're going to be discussing libraries in C programming language. That's a static library and the dynamic library. Okay. But before we move further, I would like us to just take few minutes, just few seconds, yeah, to subscribe to our channel. Please kindly click on the subscribe button. It's not going to take anything from you apart from probably just 1 KB of your data. I don't even think it's up to 1 KB. So please kindly click on the subscribe button. That is the only way that you can, support us. All right, kindly click on the subscribe button and comment and share our videos if it actually helped you. All right, so let's move on. Okay, so we want to talk about the static libraries and the dynamic libraries. Now, in C programming languages, what are libraries? Libraries are utilized by processes in order for it to run successfully. Now, for instance, you have an application that requires some functions. You might not necessarily need to put those functions in your program. So, your program only needs to refer to a library once they need some certain function to run the program. Okay, so that's basically what a library does. All right. So library can either be static or dynamic. All right. So in static library, programs utilize library at compile time. It means your program is not running yet, but it copies whatever it needs from those libraries to the program itself. So whether the library is there or not, whether you delete the library, you can still run your program. That is static because it has already copied all those files into the application before runtime. So during runtime, whether the library is there or not, you can still run your program or application successfully. That is static library. But in dynamic library, it is utilized at runtime. So it's at runtime that it refers to an external files to actually run the program successfully. So once your application or program is running, whenever it needs any function at all, it refers to the path to your library and it makes use of it. All right. So programs utilize library at runtime when it comes to dynamic library. Okay. So the extensions to these libraries varies from platform to platform. For Windows, the .dll extension is used for dynamic library and .lib is used for static library. But for the Linux, .so is used for dynamic library and .archive or .a is used for the static library. Now, usage of this library depends on the size of your programs. All right. If you're having a very large applications that has several functions, you might want to use a dynamic library because if you use a static library, it means you're going to copy all those dependencies, everything in your application, which would increase the size of your application. And size actually affect the runtime. So it makes your program really large in size, which is not too good. But if you use the dynamic library, of course, you only need to refer to um, a library when you use it. So you don't need to copy everything. Okay, it's only needed at runtime. Okay, so for there is another reason. I mean, why you might need to choose one over the other. In static library, when there is a change in the library, you might need to recompile your program. That is, if you're using a static library, you need to recompile your program to effect the change in the library, else your program is not going to run. But for dynamic library, you do not need to recompile. Once you update your library in that path that you give to your program or application, you do not need any recompilation. So your program will run based on the updated library. Okay. So for this, we're gonna let me clear my screen so that we can do a little example, write a code to show static library and dynamic library. So first of all, let's write a simple um add and okay, let's just say add and let me create a folder so I can put them there. MKDIR library tutorial. All right, so let's cd into that library tutorial. All right, so let's create a simple. We're going to use the VI editor. Let's create a simple multiplication program. VI mul.c. All right, insert. So we're going to have int mul, open bracket, int a, comma, int b. All right, return a, return a star b. All right, terminate, then close the program. All right, so we have our C program for multiplying two numbers. So the next thing, we're going to write a C program to divide two numbers. So vi div.c, right? Insert int div, open bracket, int a, int b, close bracket, curly braces, return a div b. All right, close curly braces, and of course we close the program. So don't forget that we need to write our prototype. Let's write our prototype vi main.h, right? You can name it anything, okay? But your prototype, of course, has to be the .h um, extension. So enter. All right, so we're gonna have int int. Our first program is actually multiplication, int a, comma, int b, okay, semicolon. And the second prototype is int div, that's the div.c, the program to divide two numbers, int a, int b. All right. So we're going to semicolon, and that is it. This is our prototype. This is our main.h file. So we're going to close this. All right. So what we need again, we need our main file. We already have the div file. We already have um the multiplication. Those are our C files. So you can have as many C files as possible. Now we have our header file, which is main.h, that contains our prototypes. Then what we need now is the main file. Okay, the main file is our main program. All right. Okay, so we're gonna have vi main.c. All right, enter. Insert. Here we're going to include the standard input output header, stdio dot h, right? Okay, pardon me. We need the hash. So in our main.c file, we're gonna have our header, the standard input output header, which is hash include stdio dot h, close it. Then we're going to include another header, which is our prototype, the main.h. So hash include double quotes main.h, right? Now you may want to ask why we use this sign here and then we use the double quotation here. This tells your compiler to look for this file in an external path, whatever. But here it tells the compiler to check locally for this file. So compiler knows that it doesn't need to check locally from here. It has to check, externally to get this stdio, but here it needs to check locally. It means the file is on your local computer and it needs to check it to get this file. Okay, so that is it. All right, so here we're gonna have int main, curly braces. We're gonna print f. We're gonna print f the product of A and B is percentile D, all right? And the division of A and B is percentile D. And of course, you have your new line, okay? Close quotation, comma. You call your function, right? So we're going to call our function, which is mul. That's for this, the product of A and B is actually mul. Open quotation, we can put whatever number we want to multiply, 10, 20, close, comma. They will call the division program, which is div open quotation 30 comma 2. All right, then close, terminate, and of course you return 0, terminate, and close the program. All right, so this is our main .c file. All right, so let's check what we have. ls, we have div.c, we have main.c, we have main.h, we have mul.c. So for this program, if we want to use static library, we need to first of all create our object files. And to do that, we use the command gcc, right? One, that's to convert all warnings to error, /c. Then we're going to call all our program, our C program. Okay, we're not going to include main.c, so we're going to call our C program, our C program, which is div.c, div.c, then mul.c. Then press enter. Okay, so we've already created our object file. By the time we check our files, ls, you see that we already have the object file div.o, which has the .o extension, and mul.o, which has the .o extension. So this is the object file to mul.c. If you're going to check this mul.o, let's say cat mul.o, enter, you see that in fact it's been encrypted, so you're basically seeing nothing here. It's not readable. All right, so having done that, we're going to, let me clear my screen. Having done that, we're going to merge these object files, and to do that we're going to use this command gcc cvq, right? CVQ, then the name of your object file, what you would need to name it. You can name it my prog, my prog dot a. Don't forget that you need to give the extension dot a for your library name. Okay, so this is the name of your library, my prog.a. Then we're going to merge all these object files in myprobe.a. So to do that, you can either name them one after the other, or you can either say mul.o, div.o, or you use star.o. Now this will capture all of the O files and merge them into your library, myprog.a. Okay, press enter. Okay, so we're having an issue. Okay, sorry, we're not using GCC, we're actually using AR. Sorry for that. AR CVQ, the name of your library, myprog.a dot A, then your object files, which is star.o. All right, so press enter. You can see that we already have, you know, our library created. So let's check our files. You can see that you have your library, myprog.a. All right. So since we already have our static library here, so we can compile our main file without necessarily, including the div.c program in our compilation or mol.c. Okay, so we can actually run our main program here. And to do that, we're going to use this command gcc main.c, right? Main.c, our output slash o, the name of our output, let's name it main. That's the name of our output file, our executable file. Then of course our library, which is my prog.a. So when you press enter and you check your files, you already have the executable file, which is main here. So we can run our program just with main. All right. So let's run our program dot slash main. Enter. So you can see the product of A and B is 200 and the division of A and B is 15. All right. So even if we do not have the library, okay, let's assuming that if we delete this library, we can still run main and it will run successfully. Okay. If we delete main, if we delete my this library, we can still run main because it has copied everything here. All right. So I will not want to delete it. So let's just but if you delete it on your own um system right now, you're going to do it. Okay, let's create another library. Let's create another library. Let's say I'm just going to go back to whatever. So let's do my prog one. Okay, I just used the up arrow to go through the history of all the commands that I've used. So we have AR, my slash CVQ, my program one. I'm creating another library. Okay, enter. So I already have another library, my prog one. So I'm going to compile my code, my program based on this library. And based on our history, the compilation is gcc main.c main my prog one. This time around, I'm using the library my prog one.a. I press enter. So you already have, oh, sorry, I'm supposed to change my output. Supposed to change my output main one. My output should be main one my program.a. Press enter. So let me run main one. Okay, you can see I have my output here. The product of A and B is 200, is still very correct. Now let me delete rm my prog1.a, which is actually our library, right? So I'm going to remove it now. Enter. All right, let me clear so that we can see clearly. So ls, of course, you see main one is dependent on my prog one.a, not my prog.a. My prog.a is a library for main, but main one, the library has been deleted, which is my prog one.a. So let's still run main one and see if it's going to give us output slash main dot one. All right. Sorry, slash main dot slash main one, not main dot one, slash main one. You see that the program still runs. So I think that is an advantage of static library. Even if your library has been moved elsewhere or has been deleted or has been touched, whatever, you can still run your program. But in dynamic, trust me, it's not going to be like that. It's not going to run. Okay, so this is basically static library. All right, so we can now let's move on to the dynamic library. All right, so I'm still going to use um this same file so that we'll save time. All right, so to demonstrate the dynamic library, we're still going to make use of our div and mol program. Of course, you can create another library and copy all those programs to that. I mean, create another directory, another folder, and copy those files to them. I already have, mine here. ls. Okay, I already have my div.c program, my main.c program, my prototype, which is main.h, and of course my mol.c program. So you can check all of them. Cat div.c. Okay, so this is the content of div.c. Cat mol.c. This is the content of mol.c. Then we have cat main.h. This is the content of main.h. These are your prototypes. Then cat main.c. This is the content of your main.c. So you can create another directory and have all of this in them. So while you're there, I think you should be having these 4 files in your directory. So let's go let's demonstrate dynamic library using this program. All right. Like we said earlier, in dynamic library or dynamic linking, we're not going to copy all we're not going to copy all data needed by our programs into our executable files. What we're going to do is to refer to it whenever we need it during runtime. Okay, so the first thing we're going to do is to create our object files, and we're going to use this command. We're going to use the command. We're going to use the command gcc/c gcc/c/wall/where, alright, slash fpic. Then we're going to call our C files, excluding the main.c. Please don't create any object file for your main.c file. So we're going to have div.c mul.c. Press enter. Okay, so let's check our files. ls. You see, we already have our object file for div and for mul. All right. So the next thing is to create our library. Okay. So we're going to use the code gcc/shared, right, /o slash the name of our library. The name of your library must start with lib. Okay, it must start with lib. So we can give it any name we want to give it to it. So lib, let's say lib my prog. All right, lib my prog, and the extension, like we said earlier, is .so. All right, so we're going to call our object files, which is star dot o. Okay, this is going to merge all our object files in our library file. So press enter. So ls, you can see that we already have our library file, which is libmyprog.so. Next is to build it into the executable file. And because it is dynamic library, we're going to refer to the path. Now, this part is very necessary. So you need to be very careful because if you don't refer your program to the correct path where your lib library file is going to always return an error and you won't be able to run your program. So first of all, I would advise that you first of all check your path, right? To be sure that you are writing the correct part. And to do that, you use the command readlink slash f, then the name of the file, which is libmyprog.so. Now we're trying to get the path where our library file lives. Press enter. So this is the path you're going to use. Okay, this is the path you're going to use. Although you're going to stop here because this is the name of the file. So you're going to stop here. All right. So let's build our main file. That is the executable file. All right. So we're going to give it the path to our main file. So what we're going to do is we're going to run the command gcc slash capital letter L, the path to our library file, which is slash home slash. Yours is going to be different because we're not using the same system. So that's why I advise that you always check the path to your program. So you're not going to write it the way I'm writing mine. No, you're not going to use my path. My system is quite different. So you're going to use your own path and make sure that you use the command readlink f, the program name, the file name, to check your file path before you give it in this command. So we have Aisha Linus slash Linus files, right? Linus files slash library tutorial. All right. So this is where we're gonna stop. You're not going to write this librarypro.so. You're not gonna write that. All right. So slash one, all right, slash o, which is the output. Now the name of your output. So let's use main, right? Then our main.c. You can name it anything here. Okay, let me name it my output. My output. Then your main.c file in slash L, right? Then you're gonna pick my probe.so because this is actually the name of your library file, but it is required that you use lib to start the name of your library file. So you're going to pick the name of your library file, which is after lib. The name is actually my prog. All right, my prog.so. So you're going to pick the name, which is my prog. There won't be need for any extension. So L my prog, press enter. So ls, we already have our executable file, which is my output. All right. So let's try to run our executable file slash my output. Okay. Yes, we're definitely going to run into an error. I was expecting this. We're going to run into an error. Okay. So what we need to do is to make sure that we give the R path to our executable so that it can actually locate our library file. So what we're going to do now is to run the command given the R path to our program so it can always refer to it, because at this point it cannot open the shared object file. Okay. Although it can locate it, but it cannot open it. So for it to be able to open it, we need to give the R path to our program. So what we're going to do is we're going to run the command gcc /l, the path, our path which is /home /Aisha Linus slash Linus files slash library tutorial. Okay, library tutorial and /wl, comma, rpath equals. Okay, so we're going to tell our program the path exactly /home. That's your path, the path to your library file. Arshit Linus slash shared um Arshit Linus slash Linus files. I don't really know where I belong, but you can tell me /library tutorial. You going nowhere. Okay, so /wall /output slash the name of your output, which is my output. Okay, then your main.c file in /l my prog, which is the name of your library. Press enter. Okay, I think we're having issue with our library, our path rather. I think I did not write that part correctly. Let me clear so I can see very well. Okay, read link. Let's check for our file path. Read link if my prog, lib my prog, lib my prog.so. So this is the path. So let's use the up arrow. Let's check where our program is coming from. gcc l /home /iShed Linus /Linus file /library tutorial /wl rpath equals /home /iShed Linus /Linus files /library tutorial. Okay, so our error is saying that we cannot find the arrow path. So we're going to check our command again. Let's use the up arrow. Let's use the up arrow to check where we're having the issue. All right. So let's see. Our path is okay /home Linus files tutorial. It's okay. /wl. Okay, here comma slash r part. So we missed that out, the slash there, okay? So the slash r path home, the path to our SO file, then slash wall slash output. This is our output, my output. All right, main.c, then my SO file. All right, so let's press enter. All right, so we have our executable file already. So ls, we have our executable file, my output, and we've already set the R part so that it can refer to it during runtime for any files that it needs in the shared library. So let's run our program, my output slash dot slash my output. All right, so you can see the product of A and B is 200 and the division of A and B is 15. All right, so unlike the static library, if you delete this, I mean if you delete libmyprog.so, your program is not going to run because it's only during runtime that your program refers to what you know refers to the library whenever it needs anything that your program requires to run. All right, so that is that about shared library and static library. If you've learned one or two things, please kindly drop a comment and give us a thumbs up. And of course, subscribe to our channel. You know, we do not require anything from you apart from that. That is the only way you can support us. Please do support us, subscribe to our channel, give us a thumbs up, share this video so that others can learn from it. All right, thank you. See you.